Okay, so here is our problem. So to calculate an 8-hour time-weighted average, we have concentration times time over 8 hours. So concentration times time would be 2 times 3, 2 times 2, 2 times 1, 1 times 8, 0.5 times 5, which would give us 6, 4, 3, 8, 2.5. I'm sorry for my phone calculator. I can't seem to find my calculator right now, so I'll just do this for you. 6 plus 4 plus 3 plus 8 plus 2.5 would give us a sum of 23.5 part per million hours. 23.5 part per million hours divided by 8 hours would give us 2.93 parts per million. And this would be our 8-hour time-weighted average. Weighted average. And our formula for our actual time-weighted average is the sum of concentration times time over the sum of time. So I still have my same calculation time formula here. 3 parts per million times 2 hours, 2 parts per million times 2 hours. And when I add these together, I'm going to come up with the same answer as the previous problem, 22.5 part per million hours. So this is my total. But now I need the sum of time. And that would be 2 plus 2 plus 2 plus 1 plus 0.5 equals 7.5. So we only sampled for 7.5 hours. And of course our hours cancel out there. And now our actual time-weighted average is 3 parts per million as compared to our 8-hour, which diluted that last half hour and assumed there was no exposure. One of the reasons why we tried to sample as close to our 8-hour period as we can. Okay, so let's convert our concentration in parts per million to milligrams per meters cubed. And I may set this up differently than you would. I am only now starting to understand the Common Core. So I'm going to use this 3 parts per million. And I'm plugging it into this equation, assuming I had carbon monoxide whose carbon dioxide, whose molecular weight is 44.0095 grams per mole. So here's my unknown. And this does, of course, assume that we're close to normal temperature and pressure. Okay, so I need to isolate this variable. I'll do that first by getting rid of my bottom number. Again, I apologize for my calculator. 3 times 44.0095 equals 132.02 equals milligrams per meters cubed times 24.45. And I need to bring this over through division. So now I have the answer of 5.39 equals 9 milligrams per meters cubed of CO2. And I was able to convert from parts per million to milligrams per meters cubed just by simply plugging it into the equation.